Y'all ready for this? We are here with vertex form time, the next page, and I am way too excited. Yeah! Here we go. Vertex form, if you have forgotten, is the thing that looks like this. This is technically the standard form. Boop, ba-doop, ba-doo. Like that. Your answers are going to look like this. The first one's not going to have a number in front, but it's going to have two numbers there, and it's going to be squared. This one will have a number in front, and it'll be like that. This is in the thing in the notes where there is a formula you have to know, and if you do not know the formula on the test, you will be stuck in the mud. The formula over here in the corner is b over 2 squared. Memorize it. You have to memorize it. When you come to, not if, but when you come to a section of a test that says to rewrite it in vertex form, you will recall b over 2 squared. And in which case, we don't need to know what a and c are in this case. The only thing that matters is b, or in this case, 4. So you would have 4 over 2 squared. 4 over 2 is equal to 2, and 2 squared is 4. So we're going to use that in a second, but right now we just know that it's 4. What you do is you keep the y equals, you keep the x squared, you keep the plus 4x, but then what you do is you leave some space before the plus 3. I put 2 blanks there as well to kind of space things out. But you have the x squared plus 4x plus 3, but you put 2 blanks there. And that's where the number we just had comes into play. Since we found 4, what you do is you write plus 4, and then to balance it out, you write minus 4. And the reason you do that is because that lets you factor this part into a perfect square. And by a perfect square, what I mean is when you factor it, whatever multiplies to that number and adds up to that number, they will always be the same. By that, I mean what multiplies to 4 and adds up to 4? The answer is 2 and 2, the same number twice, 2. And that is always going to be the case as long as you use this formula, that it'll be the same numbers together multiply to this, and the same numbers together add up to that middle one. In this case, like I said, the number that multiplies to 4 and adds up to 4 is 2, so it'll be x plus 2. And normally you would write x plus 2 again, but since it's 2 x plus 2's, you can just write it as x plus 2 squared. That's why it's called a perfect square. There's the y equals in front, and negative 4 plus 3 is negative 1. And that's just the answer right there. Y equals x plus 2 squared minus 1. Boom. Vertex form, right? Just like we had up here. Something with thing squared plus something. Something with squared plus something. There you go. In the previous units, we would say, oh yeah, this means the vertex is at negative 2, negative 1. We're not doing that right now, but that is getting in vertex form. The next one is more complicated because there is a negative 2 here in front. The formula only works if there is no number in front of x squared. Completing the square only works if it is just an x squared, which means we have to do something with this negative 2. And that is going to be to factor it out. We're going to factor out this negative 2, but we are only going to factor it out of the first 2 terms, the x terms. You do not factor it from the 5. Like, even if you could factor it from the 5, you don't. You only want it out of the first 2, because when you complete the square, you only use b, so you want it to affect b, but not c. So, I'm going to have some stuff out here, and then I'm going to have my plus 5 over there. I'm still going to have the plus 5 over there, but I'm going to have other stuff here. There's my blankety blank, as I like to call them. And if you factor out a negative 2, this will be an x squared. And if you factor out a negative 2 from a positive 8, then 8 divided by negative 2 is negative 4. So once again, you're taking a negative 2 from an 8, you get negative 4. And then you can go towards that formula again. Just keeping in mind, b is changed. B is not 8. B is negative 4. So you have to use that correctly. It's negative 4 over 2 squared, which is actually still going to be positive 4, just like the previous one. So you'll put plus 4 here and minus 4 here. And then I wish that was the end of the story, but it's not. Sorry. You put the plus 4 and the minus 4 to balance, but it's still technically not balanced because this 4 has a negative 2 in front of it. So you don't multiply, but if you did multiply, this would be a minus 8. So since this is being multiplied by negative 2, this also needs to be multiplied by negative 2. So hopefully that makes sense. If not, pause and look at it. But since this 4 is being multiplied by negative 2, this 4 also needs to be multiplied by negative 2. It's the balancing, the plus and the minus version. From there, y equals negative 2. What multiplies to 4 adds up to negative 4. This times it's minus 2 instead of plus 2. And then this is going to be a positive 8 plus 5. So 8 plus 5 is 13. There you go. Okay. I want to do all the imaginary number stuff in one video, so I'm going to skip this for now and come back to it. I'm going to go straight to 15. The next video will have the imaginaries, number 13 and 14. So here's 15. Find all solutions of this monstrosity of a thing. First of all, please note that if you ever have an x to the 7, that you're going to have to factor. There's no other thing. If you ever see an exponent more than 2, then you're going to have to do some type of factoring. This one looks like it has an x in all of them, so there'll be a GCF. So let's see what happens there. The greatest amount you can take out is 3, because they all have at least 3 x's. So if you factor out an x to the 3rd, then if you take away 3 x's, you would have 4 left. So if you take away 3 of them, you would have 4 left. So 2x to the 4th. If you take away 3 of these, you would have 2 left. And if you take away 3 of those, there's just the 24. And I am just now realizing that these were also all divisible by 2. So I didn't pull out the greatest common factor by accident. I should have pulled out a 2x to the 3rd. In which case that would be an x to the 4th. This would be a minus x squared. And this would be a 12. So you divide them all by 2. This is factorable. You're just not used to seeing it this way. You're probably used to seeing it as x squared and then a regular x. But you can still do this like you did before. I usually use the x method. It's what multiplies to negative 12 and adds up to negative 1. The only difference is when you factor it, you're not going to have x's here. You're instead going to have x squareds there. Because an x squared times x squared is x to the 4th. But otherwise, it's going to be the same. What multiplies to 12? Maybe 1 and 12? No. Maybe 2 and 6? No. Maybe 3 and 4? Yeah. 3 and 4. Or 3 minus 4. So 3 minus 4. Like so. And now you can set each thing equal to 0 and solve. Just keep in mind, there's multiple things now. You have to set this equal to 0. You have to set this equal to 0. You have to set this equal to 0, or factor it. I don't know if you noticed that that's factorable, but it is. I'm just not going to. Because you could still get the same answer. If you added 4 you would get that, and then you'd square root both sides. And pause the video for a second and see if you can tell me what the answer is. Because I want to see if you remember from the other videos what it is. Okay. So the square root of 4, since we square rooted both sides, the answer should be plus or minus 2, not just 2. So hopefully you remembered that when you pause the video. If not, stick it in your mind somehow. It's coming up a lot in case you haven't noticed. So square root both sides, plus or minus. This one, if you subtract 3, you get x squared equals negative 3, which when you try to square root, you fail because you can't square root a negative, and you can't really take the square root of 3 either, at least for simplifying. The most you can do is make it an I root 3, right? So x equals I root 3, right? No, it does not. It's not equals I root 3 because we took the square root of both sides, so we need a plus or minus. So there you go, plus or minus I root 3, plus or minus 2. In this one, I don't know how much work I need to show for you guys. 2x to the third equals 0. If you can just look at it and know the answer is 0, then you can just write down x equals 0 and you're fine, because 0 to the third times 2 is just 0. If you wanted to show the work, you would divide by 2. So x to the third is 0. And then if you take the third root of both sides, the third root of 0 is just 0. So everything cancels and you just get 0. And those are the answers. This is technically 5 answers. 2, negative 2, I root 3, negative I root 3, and finally 0. 5 answers. Good times. Okay. And that's it for this video. Like I said, when we come back, we're going to do these imaginary numbers, and then the back goes pretty quick. So there'll either be 2 more videos or 1, depending on how fast this goes. But I anticipate it's 2 more. So see you in a minute or a second or however much time it takes you to click.